In this tutorial, we're going to look at some image processing techniques that we can do with Python. We are very used in our modern world to taking an image and applying a filter. You can do it on your phone. There's various software programs like Photoshop that we could do it on our computer. We are used to taking these images and making them black and white or making them sepia or applying other filters like you do in Instagram. But what's really happening behind the scenes? And that's kind of what we're going to take a look at in this tutorial. Before we get started, I need you to move 2 files to your folder. And you need to complete this tutorial. I'll look for these files to grade them. Move 2 files to your folder. One is called suki.gif and one is images.py. And I have dropped both of these in your folder, your shared folder. You need to move those to whatever folder that you are going to save image practice.py, and that's the project that we're going to work on right now. So they all need to be located in the same folder in order for this to work correctly. If you had not put them in the same folder, you would get some kind of error message like this, where no module named images. Because we're actually going to import a module from some code that the textbook author wrote, so that we can more easily work with these images and kind of see some of the ways that we could manipulate images. If we open images.py and take a look, we will see a class called image, and we want to import this class into our code so that we can use this code basically. So in our image practice.py, we're going to say from images, which is the file images, import image, which is the class image. So if we come back here, see that class is capital I image. That's the code that we're importing into our program. Now, just like we did with Turtle, we need to make a new instance of this image. And I'm going to store it in a variable called image. So we are going to use my picture of Suki. So this creates a new instance of the class and stores it in this variable. And now if we want this variable to appear on our screen, we'll use the draw method. So let's save it in F5 to view in the browser. Not the browser, you know what I mean. And in Python, we were able to...
VoiceOver speaks descriptions of items on the screen.
That was weird. We were able to render this image in Python. Now, it is a GIF, so the color is not as perfect as a JPEG. So this is the JPEG that's saved on my computer. This is the GIF, and you will notice there has been some loss in the way that our pixels appear here and right there, and that's just the nature of file compression. If you want to read more on that, it's in your book on page 224. Okay, so what else can we do with this image? We can see how big this image is. So let's try that. Okay, we do have a get width and a get height method that we can use to show the width and height in pixels of our image. But before we execute this code, let's take this draw command off. We just want our resources to go towards printing this in our shell. So I'll do a save and F5, and it says the image's width is 696 and the height is 718. Now we can also get specific pixel values of our image. Let's see what that looks like. So I'm using the method getPixel on the image, and I'm saying 0, 0, which probably means coordinates. And if you type that in, you probably saw XY value, and that's exactly what that means. It's coordinate value. Let's take a look by running this, and we'll see 22, 42, 6. What does that mean, I wonder? Do you remember that from HTML? Rgb values. Rgb values are red, green, blue values. And if we red, green, blue that value, this is what color it is, this dark green here. Okay? So if I look at my image again, where is this a dark green? Would it be here? That doesn't look like a green at all. Okay, so unlike turtle, in turtle, our 0, 0 was the exact center of the screen. Image processing uses a screen format. So when we're looking at a coordinate system for images, it starts in the upper left-hand corner, as it did in web design. So the pixel that it is referring to at 0, 0 is this pixel in the upper left-hand corner. Okay? What if we said, like, let's look at a middle pixel. Let's just say about 350 to 350. And we'll run this again. And let's see what RGB value this is. So let's copy this over. I'm just going to use Google here to help us find this. And it is a purple. Did you expect to see a purple? But yeah, if you look there, that does kind of look like those colors that are in the cat that appears to be a gray and white calico cat, but it turns out there's purple in it. So kind of neat. Okay, so if we can get to these pixels to see what the pixel value is, then of course we can change those pixel values. So that's what we're going to do, but think about how we would do that. So there are 696 pixels across this image, and the GIF, but I'm looking at the JPEG. Let me open the GIF. There we go. There are 696 pixels across, and there are 718 pixels down. So if we wanted to do some kind of code that would look at each individual pixel, how would we do that? Well, in programming, a nested loop would probably be our best bet in trying to access each individual pixel in this image. For a nested loop, we're going to tell our loop to go all the way across the first row, and then when it gets to the end of the row, it'll loop back to go all the way across this second row, and so on and so forth. So let's look at some nested loops just to kind of refresh our memory before we try this code. Okay, so this is just kind of for practice. Okay, so let's look at this nested loop. This loop is going to 4 times iterate all of the body of the loop. In the first iteration, the value of I is 0, so it's going to print outer loop 0. Then it begins the nested loop, and this loop is going to iterate 4 times as well, beginning at 0 and counting up till 3. When it completes its loop process, it returns to the beginning loop, the outer loop, and I's value is now 1. It will print 1 and then continue this loop 4 more times. So let's see what this looks like when we run it. Okay, is that what you expected? Our outer loop printed 0, and then this inner loop iterated 4 times, printed till 3, and then it sent the code back up to the beginning of the for loop where I was then 1. Then our inner loop iterated again 4 times. It sent the code back up to the beginning, the outer loop, where I now had a value of 2, and then it iterated 4 times, and finally the last iteration of the body. So that is essentially what we're going to do with traversing our image so that we can go each row for every column. Okay, go ahead and open up, save that one, and then open up a new PyScript, and we'll save it as blackandwhite.py. Make sure you're saving again in that same folder because we need to be able to access that images.py file and then that suki.gif. And this code again will import from the images module, the class image. We'll create a new instance of that. And in this function, we're going to do a lot of different things. So let's remember what was the hexadecimal value of black. If we wanted to make something black, we used hashtag FFFFFF. Well, in RGB, that's 0, 0, 0. Okay, so we got a black pixel, 0, 0, 0. We've got a white pixel that is 255, 255, 255. That is white. It was FF, FF, FF in hexadecimal, but in RGB it's 255. That's because with RGB, if you remember from HTML, each red, green, or blue can have a value of 0 to 255. It could never have a value of 340. It can have a value of 0, 1, 2, and then all the way up to 255. This is the value for the red, this is the value for the green, and this is the value for the blue. So for each Y, so for each column, we are going to get the height, and then for each row, we are going to get the width. We are going to get the pixel value, the red, green, and blue value of that particular pixel in the loop. We are going to average those. This is just a way of determining if it should be a black pixel or a white pixel when we transfer it to black and white. So if the average is below 128, we're going to set the pixel at that value to a black pixel. If it is above 128, then we're going to set it to a white pixel. Okay? Then let's call that function and send it our image, which is Suki, and then we'll do image.draw to print the image to the screen. Now do that. If you need to pause to copy your code over, do so. But when we execute this code, it's going to take it a minute. Now don't get impatient because it does take a few seconds for it to load the image, but you would have this code. So it looks like a very bad Xerox copy of an image, but we did write code to make these pixels change from the colorful pixels that they were to either a black pixel or a white pixel. Now, if we wanted to save that image, we could do so. I'm going to show you how to do that in the next project. But for now, let's just close that out. Since a lot of this code we can use, well, not a lot, we can use this again if you want to copy that code. And we're going to create a new document and we're going to call it grayscale. So copy this code over and I'm going to go ahead and type the rest so you won't have to listen to me type. Okay, so this is going to take that original image of Suki and change it to a grayscale image, which is more of a well-defined black and white image. So again, we do need to import our module, our class image, create a new instance of that class that will represent Suki. And then in this loop, we're doing basically the same thing, but this time, look what is happening here. When we get the pixel of the red, green, and blue value, we're multiplying it by these random numbers. Now, if you want to read this in the book, it's on page 232, but basically it explains that the human eye is more sensitive to green and blue than it is, green and red than it is to blue. So they have determined the relative luminous proportions, which are these numbers. So we're using those numbers to determine the relative luminous, and then basically changing those pixels in that particular value to whatever the result of this is. Now in this case, when we call this function and draw it, this time we're also going to save it. So image.save and give it a new name. So I said grayscale Suki, and you do not put .gif on the end of that. It will automatically save as a GIF as part of this images module. Okay, now this module, I don't know if I said, this was written by the textbook author, so it's not, widely used. There would be other images module if you wanted to do other types of imaging processing. We're just trying to practice with the fact that we can import modules from other people's code. Okay, so let's, you either pause this and copy this code over, and if you're ready to execute the code, let's do a quick F5. And again, it's going to take a few seconds, so be patient. All right, now we have a more defined black and white picture of Suki. Notice that this image looks a lot better than that black and white image that we had in the previous assignment. So that's pretty cool. We took an image and we used code to change the color value of each pixel. So that's pretty cool.